Hello, everyone! Have you ever stopped to think about what's actually happening when things, well, combine or break apart or even swap partners? It's all the magic of chemical reactions. And you know what? Today, we're going to make them super simple to understand and remember. Let's get started.
I mean, just think about it. From the sizzle of cooking in your kitchen to a rusty old nail lying outside, chemistry is literally all around us. But here's the cool part. These reactions aren't just random chaos. Nope, they actually follow specific patterns. It's almost like a secret code. And today, you and I are going to crack it together. So are you ready? Let's jump right in.
Okay, first up, let's look at two reactions that are basically opposites. Like two sides of the very same coin. One is all about building something bigger from smaller bits, and the other, well, it's all about breaking one big thing down. Let's see exactly how they work.
So a combination reaction, it's really as simple as it sounds. Just imagine you take some quicklime and add a splash of water. What happens? They don't just mix, do they? No, they react with this sizzle, creating a totally new substance called calcium hydroxide, and get this, releasing a whole lot of heat that you can actually feel. How cool is that?
And here's the super easy way to remember this. It's my little trick for you. Just think, many things come together to become one single product. Many arrows pointing to one. It's like teamwork, right? So remember, many becomes one. Simple, isn't it?
All right, now let's completely flip the script. If combination was about putting things together, decomposition is all about, you guessed it, breaking things apart. We start with just one compound and we break it down. Take limestone, for instance. When you heat it up, it just can't take it, and it splits into two simpler things, quicklime and carbon dioxide. It's literally one big thing breaking into smaller pieces.
So, naturally, our memory trick here is the total opposite of the last one. It's so easy. One thing breaks down into many things. One becomes many. That's all you have to remember. Simple as that.
Okay, you're ready to spice things up a bit? Because our next set of reactions is all about swapping places. You can think of it like changing partners in a dance. So get ready for what I like to call the great switch.
Okay, so in a displacement reaction, it's basically a battle of the elements. The stronger, more reactive element will always win. It just comes in and kicks the weaker, less reactive one right out of its spot in the compound. It's a total chemical power play. Just look at this. When we put a shiny iron nail into this bright blue copper sulfate solution, something really cool starts to happen. After a little while, you'll see the nail gets this brownish coating, and that beautiful blue solution, it starts to fade away. Why? That's the iron flexing its muscles and kicking the copper right out.
But hang on, you might be asking, how do we even know which element is stronger? Well, that's where this handy thing called the reactivity series comes in. Just think of it like a chemical leaderboard. The higher an element is on the list, the more powerful, reactive it is. And as you can see, iron is higher up than copper, and that's what gives it the power to take over.
So what happens if it's not just one element kicking another out? What if everyone decides to switch partners at the same time? Well, that's when we get a double displacement reaction. It's like a total swap meet where two compounds just trade their ions, forming two completely new compounds. It's a full-on chemical dance-off.
And here's the best part. You can often see this one happen right before your eyes. When you mix two perfectly clear solutions, like sodium sulfate and barium chloride, poof, a solid suddenly appears out of nowhere. That amazing solid is called a precipitate, and it's a dead giveaway that a double displacement reaction has just happened. It's a mutual swap that gives you a very visible result.
Wow, we have covered so much ground, and you're all doing absolutely amazing. So, before we wrap up, let's do a super quick recap, just to make sure all these new ideas are locked in your brain for good. Ready?
All right, let's run through them one last time. Combination, that's many to one. Decomposition, one to many. Displacement, the more reactive replaces the less reactive. And double displacement, it's an exchange of ions, a total partner swap. See? You've got this. You're practically a chemical reaction expert now. And there you have it. You've just mastered the four main types of chemical reactions. Seriously, you should be really proud of yourselves. Keep asking questions, keep being curious, and keep exploring the amazing world of chemistry. Thanks so much for learning with me today at Crush Concept Academy.